CS 3351 Digital Principles and Computer Organization. Topic is registers, presented by Devi Salaksha, Assistant Professor of CSE Department, Rohini College of Engineering and Technology. Registers. Flip-flop is a 1-bit memory cell which can be used for storing the digital data. To increase the storage capacity in terms of number of bits, we have to use a group of flip-flops. Such a group of flip-flop is known as registers. The n-bit register will consist of n number of flip-flop and it capable of storing a n-bit word. The binary data register can be moved within the register from one flip-flop to another. The registers that allow such data transfers are called shift register. There are four modes of operations of shift registers: serial input, serial output, serial input, parallel output, parallel input, serial output, input, parallel output. So first we can see serial input, serial output. Let all the flip-flop be initially in the reset condition, that is Q3 equal to Q3 equal to Q1 equal to Q0 equal to 0. If an entry of a 4-bit binary number 1111 is made into the register, this number should be applied to DN with the LSB bit applied first. The D input of 3, that is D3, is connected to serial data input D in. Output is of 3, that is Q3, is connected to the input of the next flip-flop, that is D2, and so on. Serial input, parallel output. In such types of operations, the data is entered serially and taken output in parallel fashion. Data is loaded bit by bit. The output are disabled as long as the data is loading. As soon as the data loading gets completed, all the flip-flops contain their required data. The outputs are enabled so that all the loaded data is made available. Overall, the output lines are the same line. This is the block diagram for the serial input, parallel output. Parallel input, serial output. Data bits are entered in parallel fashion. The circuit shown below are 4-bit parallel input, serial output register. Output of previous flip-flop is connected to the input of the next one via the combinational circuit. The binary input word B0, B1, B2, B3 is applied through the same combinational circuit. There are two modes are available in this parallel input, serial output. One is the shift mode and second one is the load mode. When the shift or load bar lines is low, the AND gate 246 become active. They will pass B1, B2, B3 bits to the corresponding flip-flops. One is low going to the clock. The binary input B0, B1, B2, B3 will get loaded into the corresponding flips of the parallel loading takes place. Shift mode. When the shift or bar line is low, the AND gate 246 become inactive. Hence, the parallel loading of the data becomes impossible, but AND gate 135 become active. Therefore, the shifting of data from left to right bit by bit on application of clock pulses. This is a block diagram for just we are giving the parallel inputs and then we are receiving the outputs. Parallel input, parallel output. In this mode, the 4-bit binary input B0, B1, B2, B3 is applied to the data inputs D0, D1, D2, D3 respectively of the 4 flip-flops. As soon as negative clock edge is applied, the input binary bits will be loaded into the flip-flop simultaneously. The loaded bits will appear simultaneously to the output side. Only clock pulse is essential to load all the bits. This is the block diagram. So just we are giving the input as parallel and then we are receiving the parallel outputs also. Bidirectional shift register. In the binary number is shifted left by 1, then it is equivalent to multiplying the original number by 2. Similarly, if a binary number is shifted register by 1 position, then it is equivalent divided by original number 2. Hence, if we want to use the shift register to multiply and divide the given binary number, then we should be able to move the data in either left or right direction. Such a register is called bidirectional register. A 4-bit bidirectional register is shown below. There are two serial inputs, namely the serial right day shift data input DR and the serial left shift data input DL, along with the mode select input. Universal shift register. A shift register which can shift the data in which only one direction is called as unidirectional shift register. A shift register which can shift the data in both directions is called as a bidirectional shift register. Applying the same logic, a shift register which can shift the data in both directions as well as load it parallelly is known as universal shift registers. The shift register is capable of performing the following operations: parallel loading, left loading, and right shifting. The mode control input is connected to logic 1 for parallel loading operation, whereas it is connected to 0 for serial shifting, with mode control pin connected to ground. The universal shift register acts as the bidirectional registers for serial left operation. The input is applied to the serial input, which goes to AND gate 1, that will be shown in the figure. This is a block diagram for universal shift registers.